Hello everyone, welcome back to my YouTube channel. In this week video, I'm going to explain to you the numerical question asked in the test 1. So let's get started. Question number 1. The data set of the listed values has an outliers with the aid of the critical value of G as tabulated in the table below. Briefly confirm if the outliers should be removed from the data point within 95% confidence level. Alright, so in order for you to answer this question, we are going to look at the values given to you in the question. And from this value, you need to find which one of these are the outliers. So if you can see here, we have the number like 82, 73. So it's around 70 and 80. So therefore, we can say that 60 here is our potential outliers. Alright, so moving on, in the question, you were given the critical value G. So you have this critical value of G. So it means that the thing that you can actually calculate is the G test. So in order for you to calculate the G test, the first thing that you need to do is you need to calculate the average. So the average, so in order for you to calculate the averages, you need to find what is the summation of all this value. So we are just going to add this number 82 plus 72 plus 83 plus 75, and then goes 80, 78, 82, 73, and our outlier is 60, and lastly 79. So this value, you need to divide with 10 because you have 10 values altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you divide that with 10, so you will get your average is 764 divided by 10. Hence, you should get 76.4. So this is your average. Alright, so from the calculation that we have done just now, we get our average is equivalent to 76.4. So the next up that you need to calculate is the standard deviation. So standard deviation is equivalent to the summation of the value, each value that you have here, minus your average, and then you need to do to the power of 2, and then n minus 1. So your n is actually 10. We have calculated just now. The total number of values that were given to you is 10. Therefore, you can say that it's supposed to be the summation of x minus the average. So I'm just going to write like this. So 10 minus 1 is equivalent to 9. So basically you need to do one by one for the calculation of all these values. So you should get the standard deviation is the square root of 47.8222. Therefore, you will get your standard deviation equivalent to 6.9153. Alright, now, so I'm just going to go briefly on how you should calculate this part. Alright, so I'm just going to take an example for the first number. So the first value that is given to you is actually 82. So what you're going to do is x minus the average. So, and then you need to square root the value, right? Like this. So for example, your value is 82, and from the average that we have calculated just now is 76.4. So you should get you just have to minus this, so you should get 5.6 to the power of 2. So the value that you want here should be 31.36. So what's left for you to do is you are going to do the same calculation as this one, and then you are going to do the summation of this value for all the numbers given to you in the question. Therefore, you should get the summation of the values should be 430.4. So this value should be inserted inside here. So in other words, we can say that for the calculation of standard deviation, you can also write like this: 430.4 divided by 10 minus 1. Therefore, you will get this value here, and at the end, you shall get 6.9153 as your standard deviation. Okay, so just a short recap. We have calculated our average to be 76.4 and our standard deviation to be 6.9153. So what's left for us to calculate is the g-test. So in g-test, the formula is equivalent to the modulus xq minus your average divided by your standard deviation. So your xq is actually your outliers. So your outliers is 60 minus your average here. So your average is what we have calculated just now, 76.4. Remember, we have modulus here, so it doesn't matter if it becomes negative. And then your standard deviation here is equivalent to 6.9153. Therefore, you will get your g-test equivalent to 2.3716. Right. So next up, what we are going to do is we are going to look at the table given to you. So basically, in the question, it wants the data point to be at 95% confident level. So we are going to look at the 95% confident level. And then the value of n. So we have 10 data points altogether. So n is equivalent to 10. So your G critical is equivalent to 2.290. So don't get confused, okay? Because we are going to do the G test. So this is just n, not n minus 1. So given to you, your G critical is equivalent to 2.290. And your G test, which you have just calculated, is equivalent to 2.3716. So apparently your G test is actually bigger than your G critical. So what we are going to do when your G test is bigger than your G critical, therefore we need to remove the outliers. Alright, so this is the final answer for the first question. Alright, let's move on to the second question. Examine the accuracy of a chemist's hypothesis which states that 3.8 times 10 to the power of negative 19 joule of energy is necessary for an organic molecule to vibrate at a wave number of 808.0808 per centimeter. Provide a brief explanation to support your evaluation. Right, so let's look at the question now. The energy given to you is 3.8 times 10 to the power of negative 19 joule with a wave number of 808.0808 per centimeter. So the first thing that you need to calculate is how you can convert this wave number, because this is not a wavelength given to you. You were given the wave number into the wavelength. So wave number is equivalent to 1 over your wavelength. So given to you is the wave number 808.0808 per centimeter is equivalent to 1 over lambda, which is your wavelength. So your wavelength should be equivalent to 1 over 808.0808 per centimeter. Therefore, your wavelength should be equivalent to 1.2375 times 10 to the power of negative 3 centimeter. So this is your wavelength. This is the first thing that you need to know in order for you to get back what is the energy needed. Alright, so since we already know what is the wavelength, so from the data of the wavelength, we can actually get what is the frequency. So the wavelength is equivalent to the speed of light divided by the frequency. So from there, we know that our wavelength is this value. So 1.2375 times 10 to the power of negative 3 centimeter is equivalent to the speed of light, which is 3.0 times 10 to the power of 10 centimeter per second divided by the frequency, which is the value that we want to get. So therefore, we get your frequency is equivalent to the speed of light, 3.0 times 10 to the power of 10 centimeter per second divided by 1.2375 times 10 to the power of negative 3 centimeter. Therefore, your frequency is equivalent to 2.4242 times 10 to the power of 13 per second. So this is the value of the frequency. Alright, so from our calculation just now, we know that the wavelength is 1.2375 times 10 to the power of negative 3, and our frequency is equivalent to 2.4242 times 10 to the power of 13 per second. Therefore, from here, we can find what is the energy. So energy is equivalent to the Planck constant times the frequency. So the Planck constant is the constant value 6.6 times 10 to the power of negative 34 joule second, and then your frequency is the one that you have calculated just now, 2.4242 times 10 to the power of 13 per second. Therefore, you will get your energy is equivalent to 1.5999 times 10 to the power of negative 20 joule. Alright, so let's look back to the question. Provide a brief explanation to support your evaluation on the accuracy of the energy. So given to you, the energy is 3.8 times 10 to the power of negative 19 joule. So the exact value that we have calculated is actually 1.5999 times 10 to the power of negative 20. So this one is the actual value, this one is the hypothesized value. Therefore, we can say that the hypothesis is inaccurate. Alright, so this is the final answer for the second question. Okay, let's move on to the third question and the last question for this week's video. Point out the potential absorption maximum, lambda max, and identify the shift in the case of cinnamonic acid as depicted in the figure below, considering that the benzoic acid exhibits an absorption maximum lambda max at 230 nanometer. Okay, so this question is a rather straightforward question. There's not much calculation that you need to do. So we are going to evaluate the structure of benzoic acid. So in benzoic acid, you can see here you have double bond and then with double bond. Okay, if you compare with the cinnamonic acid, we have here double bond, conjugated, and then we have another conjugated. This is longer conjugated as compared to benzoic acid. So basically, because you were asked to point out the potential absorption maximum, so we can say that the cinnamonic acid have longer conjugation. So you will get 1 point here. And then the cinnamonic acid should have a lower energy gap, hence showing a bathochromic shift. You need to write a bathochromic shift. or in other words, we can say a redshift. So why it does a redshift? Because it have a longer conjugation. So basically, if you want to connect it with the energy, you can also report it as the structure with conjugated double bond or longer conjugated double bond will actually have lower energy. So once it have lower energy, therefore it will have the lambda max at a higher wavelength. Alright, so in this case, you were given the wavelength for the cinnamonic acid. So your cinnamonic acid is 230 nanometer. So point out the potential absorption maximum. So the potential lambda max of this cinnamonic acid should be higher as compared to the benzoic acid because it have longer conjugation. So you may predict that the lambda max for this shall be at the range of 260 nanometer till 270 nanometer, or any number that is above 230 nanometer. Alright everyone, this is the end of this week's video. Thank you very much for watching this video from the beginning until the end, and I hope that this video will help you to understand how you should tackle questions from chapter 1 till chapter 3. So I'll see you again next week. Take care and be good. Goodbye.